Alright, so here we're going to recap what we learned about lines of best fit, and we're going to talk about a curve of best fit, which is basically a line of best fit, but we're now dealing with quadratics, so it's going to be a curved line instead of just a straight line. It's going to be a quadratic function instead of a linear function. Before we get into that, we're just going to talk about what a correlation is. A correlation relates to a line of best fit, and it basically is just telling us whether it's a positive, negative, or no slope at all. So this first one, these dots are just scattered around. There doesn't seem to be any connection between the x and the y. As we go across, it's not going up and down. It's not really any sort of pattern, so there is no correlation. On the second one, we see that that is trending downwards. We can draw a line of best fit, at least a sketch one, that goes through the middle of that. That has a negative correlation. And the third one, we're really just looking at the slope there of our line of best fit, which cuts through the middle of those points. That has a positive correlation. That mostly deals with lines of best fit when we can easily tell a slope. A curve of best fit won't have at least it won't have a consistent slope. It's going to change as you go throughout the curve. So a line of best fit is a linear function, just like I said before. And it always shows the relationship between relationship between two sets of data. That's what we're seeing here. We have the temperature on the x-axis. We have the price or cost, I'm not even sure what that is, but the money value on the y. As the temperature goes up, so does the price. That has a positive correlation. A curve of best fit is a quadratic function. That also shows the relationship between two sets of data. It just shows a more complicated relationship. It's not proportional. It doesn't just strictly go up. As this x goes up, the y starts to go up, and then it comes back down. It's not just the same thing over and over. It's not always a positive correlation that we see in the beginning. It slopes out to basically a zero correlation. This is positive. Then it becomes a zero correlation, and then it becomes a negative on the way down. So we need a curve to describe that relationship. To come up with the actual equation for both of these, the line and the curve of best fit, we're going to use the calculator. We've done this before. I'm going to walk through it one more time. To find the line of best fit, we're going to hit stat. Oops, we're going to turn that on again. We're going to hit stat right in the middle, then select edit. And then we're going to type in our x and y values. We're going to type in this for list 1 and this for list 2. So I'm going to type in 1, 2, 3, 4, 5, and 6. After you hit each number, you can either hit the down arrow or you can hit enter. And then go over to list 2 and type in the y values, 2, 4, 5, 7, 9, and 11. So now that we have our table in list 1 and list 2, we're going to hit second and quit. Oops, second and quit, just to go to the main screen. And then we're going to select the stat key again. Actually, I think we could have just hit the stat key and it would have gone right back there. But now we're going to go over to calc. And we're going to select the linear regression. We're trying to make a line of best fit. So we're going to use a linear regression, which is going to give us basically slope-intercept form of the equation. And we want to use list 1 and list 2. Sometimes you might need to change these two. But right now we have list 1 and list 2 in there, which is exactly what we want. We want the x value to be list 1, which is what that is showing. And we want the y value to be list 2, which is what that's showing. We don't really need to change anything else about this. Yours might look a little bit different. You might just have to hit enter. I have to go down to calculator and hit enter there. And that gives me my coefficient of x, the a, which is 1.77. Oops. So my coefficient, or really the slope of the line of best fit, is 1.77 times x plus the b value, which is the y-intercept, the b there, plus 0.13 repeating. That's the equation of the line of best fit. The a goes in front of the x, b goes really where b is in slope-intercept form. Now this follow-up question asks, what's the value of y if the x value is 14? That's basically just saying x equals 14, plug that in, figure out what y equals. So I'm going to substitute that in. I'm going to do 1.77, so I'm going to do it on the calculator. 1.77 times 14 plus 0.13 repeating. I'm just going to type in a bunch of threes. And that equals 24.9. So on this table, I can predict that when x is 14, the y value would be 24.9. Okay, so just out of curiosity, we're going to look at the graph also. We have to change the settings on our calculator. We have to change the stat plot to be on. So you hit second and stat plot, and we're going to hit enter and on. This is exactly what it's supposed to look like, list 1 and list 2. And now we're going to look at the graph. So that actually doesn't include all of our points. You can see that 11 is actually not going to be on this graph. 6, 11 would be just off of that. So we're going to hit zoom, and we're going to go down to stat. It's going to zoom into whatever statistics we've put in. So that includes all 6 of our points. But our line of best fit is not on there right now. So now I'm going to type this into y equals. That's just an equation that I can type in to give me a line. So I'm going to write 1.77x plus 0.1333. I'm going to type in a bunch of threes and look at that graph. And that is my line of best fit. It cuts right through the middle of most of those points. For the next one, we are going to use a curve of best fit, which means it's going to be a quadratic. So we're going to go back to stat and hit edit and change our list. Oops. So it's the numbers 1 through 6. And then for list 2, or our y values, which is the height of these golf balls. So this is describing the time. So after 1 second, the height is 15. After 2, it's 40. After 3, it's 45. And then after 6 seconds, oops, should be 2. So that describes the time. That's our x value. And this describes the height of the golf ball. So far we've completed steps 1, 2, and 3. We've just typed in our list. Now we really don't even have to do step 4. We can just hit stat again and then go over to calc. And we don't want a line of best fit anymore. We want a quadratic of best fit, a curve of best fit. So we're going to hit quad reg, and it's going to give us something in this form: ax squared plus bx plus c, something that's quadratic. We still want to use list 1 and list 2. So I'm going to hit calculate, and it's going to tell me my a, b, and c that can be put into this equation. The coefficient of x squared, that's this negative 5.25. The coefficient of x is a 31.75. And then we're going to write minus this 3.29. I'm going to round that to 29 as my c. So that is my equation of my curve of best fit. The next part is asking, what's the y value if the x value is 4.5 seconds? So basically that's just asking us to take 4.5 and plug it in for both these x's, figure out what the height's going to be. After 4.5 seconds, what's the y value or the height going to be? And I'm going to do this in a little bit of a quicker way. I'm going to go back to stat, hit calc, get my quad reg back up there. And I'm going to store my equation in for y1. So I can hit VARS and then go to Y VARS and hit enter, and basically it's just going to store it in for y1. It's basically just going to put it in for my first y equals without me having to type it in. You don't have to do that on your own. You could just go over, I'm going to hit calculate just so it does it, but it's already stored it there. You could just go over here and type it in just like we did before. Just type this equation in for your y1. I just had the calculator do that for me. So now I have my equation in there. And the nice thing about this is none of the decimals are rounded now, so you're going to get an exact answer. And I'm going to look at I'm going to make sure, actually my stat plot is already on. I know that because it says plot 1 is on up here. So I'm going to look at my graph. And those points don't really come up. Some of them do. You can see the beginning of the graph there and the end of the graph here, but we want to zoom and have it fit our statistics. So I'm going to hit zoom stat, and then that should show me my points and my quadratic to fit as the curve of best fit. Now, what I really want to answer is what is it at 4.5? What's the y value at 4.5? So I'm going to hit second. Again, you could just plug this in. You could just actually follow order of operations with 4.5 as your x, or you can hit second in calc. And remember, we can use this value function to type in an x value, and it'll give us the y value. And by doing that, it's telling me that when the x value is 4.5, the y value is 33.2, I'm rounding that to 8, 33.28 feet in the air after 4.5 seconds. So that's where the ball is, right about at that spot in this trajectory.